In this conversation, I'm going to take you through Kubernetes, containerized environments, and the meaning of real tracing in such distributed natures. As Molly mentioned, I'm Ran, the co-founder and CTO at Epsagon. At Epsagon, we're building exactly these kind of things, but we're not here to talk about Epsagon. We're here to talk about tracing and Kubernetes. So the things that we'll cover today, starting with what are the challenges today in microservices environments, and especially container-based environments. How do we do right observability in such environments? How do we, which monitoring tools and open source tools we got under our sleeves to help us do this? And then, just as a quick tip for the end, how would we do it in best practices? Like, if you'll go out with this session that you want to do this as well, I'll give you some good tools to get started. So let's get going. And by the way, feel free to ask questions throughout the conversation. I'll try to answer them as we go by. Let's start first with why are we even here, or why do we bother about Kubernetes, microservices, complexity of applications? Now, we know that our application changed dramatically over the course of the last 5 years or so. We moved it from monolithic applications running on data centers to more and more microservices approach, and then even to highly distributed applications composed with cloud resources, third-party APIs, managed vendor solutions, which ultimately turns us to become from host-based monolithic application to something that is more abstracted, that is more distributed. And it's really getting harder to monitor and troubleshoot such environments. And I'm going to touch about these points very soon, but just, if you don't believe me, the new era is completely cloud, completely based on containers. It can be any kind of orchestration level and any kind of containerized level, varying from Docker to any other environment, and Kubernetes and ECS and AKS and any kind of flavor today that really takes our application to the next level. Now, if you're convinced, I think that we're introducing different kind of challenges. Obviously, there are lots of advantages for such environments, but one of the main challenges that's starting to rise is the complexity of the application, which if you can look on the right-hand side, you'll see an example, a user is having some issues with our application, and now we're the one that needs to troubleshoot it. Now, troubleshooting not always as easy as it sounds, especially when it's broken down to several services. And in this case, we want to be able to troubleshoot faster, but unfortunately, we're the ones that need to correlate each and every service and each and every path along this route, which can be quite complex. Now, I've talked so far just about a single event of an error. What about just understanding the overall performance? How long this kind of path take from end to end? Is there any bottlenecks or specific issues rising up with that? And how does my whole application even looks like? This is, just a single path within my application. What's the overall application looks like, and where do I got any issues that I need to look for? Now, most of the tools in this kind of scale usually are doing sampling or just logs, and you can't see all of the payloads, which pretty much lacking the ability to operate and troubleshoot such environments. Now, especially if we're taking this into the Kubernetes era, a high number of distributed components, running on several clusters, several nodes, several applications and services and deployments, all are communicating to one another, which makes all this abstraction level quite complex, because so far, we used to have a single host that we could connect to. We knew exactly where each application would run, but now every application can spin up and down dynamically on different pods, containers, hosts. It's really hard to track down this interconnectivity and all of the abstraction layers. And especially when we're talking about something that is so dynamic that Kubernetes, scheduling the workloads for us. We're not the one that's starting the service. Kubernetes is starting and stopping services all over the place for us. And this is just the ecosystem of Kubernetes. I'm pretty sure that for each and every one of you, there is at least one third-party API that is using, if not tens of them, that are making things even more complex, like databases, storages, web servers, queues, and so on. So this is getting really complex, especially in Kubernetes environments. And the first solution today to come up with, with just a proper, or I'd say even a basic monitoring for that, comes in the form of Prometheus, which is open source. I'm pretty sure that everybody knows the name. Anyone that knows Kubernetes will probably know Prometheus. It's the open source part of the CNCF, the Cloud Native Foundation solution, that helps us to ship metrics. In other words, this is just an aggregation for metrics, or we can call it even a time series DB, that we can push metrics about the nodes, the pods, services that are running, for example, Kafka service or my application service. Anyone can export metrics into the metrics endpoint of Prometheus. And again, it comes as some existing in the market exporters. For example, export things from my CloudWatch, export things from my Kafka, from my Nginx, or whatever service that I'm using, or even give me some code because I do want to export some business metrics or application level metrics that only I can see. Now, Prometheus likely also support alerting, so when something goes wrong, we're getting notified because none of us likes to sit in front of the dashboard to wait for a problem. And ultimately, we need something to visualize it because Prometheus is just, or I would say, is the main engine that supports having all this information and shipping the alerts, but we need something that will be nicely to see that, to configure dashboards, to visualize the metrics that we're having. So luckily for that, we got Grafana that comes as an open source or a managed solution that can give you very quickly and very nicely some nice dashboards. So here we can see an example dashboard that we built for the application level metrics. For example, how many, like what it takes to load a page on our application, how many logins, how many errors, and duration, including percentage and things like that, which is super important for us when we're monitoring our application. And again, this was pretty straightforward to build out with Grafana, very simple as that. Also, another example is a Kubernetes monitoring for Grafana. If you want to look at, for a specific, for example, pod that is running, usage, the CPU usage, network in and out, disk operations, TCP connections, and processes and other things like that. This can easily be achieved with custom dashboards in Prometheus, sorry, in Grafana, and also we can set up things like built-in dashboards, or just switch between pod to pod or node to node to understand exactly what's going on in our stack. Now, if you're using already Prometheus and you're having quite a large scale with lots of environments and Kubernetes clusters and users and teams, you'll pretty much understand that very quickly it becomes a pain to manage all of these things. So luckily, there are some centralized metric systems that help us to take Prometheus to the next level. That offers things like Thanos and Cortex that will help us do long-term managed storage because Prometheus out of the box do not come with persistent data storage. So things like shipping it out to S3 or any other service. Also horizontal scaling, because one Prometheus can handle a certain amount, but what about 100 times of this traffic? Will need horizontal scaling, and also multi-tenancy if we have several environments and so on. Now, some of the leading systems, if you're out there and looking to explore them, Thanos, Cortex, Victoria Metrics, and M3, all of them are great. Each one has its own advantage to here and there, but they will give you a good starting point to scale out Prometheus. Now, we still haven't talked about some of the problems that we're having. Observability level that we can aggregate them, build dashboard, which is kind of nice. Then we got the logs, which tells us whenever there is a problem, I'll dig into the problem and see what happened. And tracing tells us the path of the story along this chain of events. So in this way, I can understand exactly what happened. So in other words, these three pillars of observability will be able to tell me what happened using the metrics. For example, a high errors, why they happen. Using the logs, I'll be able to figure out why these 500 errors are happening. And traces will tell me the path, because it's not necessarily happening on the first service that the user encounters. It can be several chains along the path once the problem really occurs. So all of them, if I'll combine all of them together, it will give me what, why, and where in a single pane of glass. Just before we dive into the tracing part of it, let's review some of, how do we do monitoring and logging today. So the most old school or traditional, I would say, monitoring approach is kind of based off heavy instrumentation or an agent-based approach that will live on my host or my service or my container. It means that if I'm having some business logic that incomes a REST API and calls some database, I'll need to install an agent that will collect these metrics for me. Now, one of the main problems with this kind of, or this approach, is that it collects only the host data. It doesn't collect any information within the application or something that will tell me actually what went along a chain of events. And it collects just metrics. It means that if I'm having a problem, for example, 500 error, I don't really know what happened. And in order to know exactly what happened, I'll need to explore the logs. Or to troubleshoot it, I need some debug data, or you already know it's the logs. And we call it, it's yet another agent sitting over there. There are tons of agents, whether you're using Elastic or Splunk or some other managed service or CloudWatch. In any kind of solution, you'll need to deploy another thing that will listen to the logs, the local logs, and will dump them somewhere else. Most of the logging tools are quite expensive because they will do for you a lot of things that you don't necessarily need to do. For example, like indexing information, aggregating it, building alerts on top of it, and dashboards. But we definitely need some logs. And the main problem with logs, or the inherent problem with logs, is that whatever you didn't log in the code will never get to the logs. So if you had a problem that you didn't log out, or you missed a parameter that you wanted to look at, it's just gone. You can probably log into the specific node and see what happened, but if you miss some time, it probably won't be there anymore. And it's expensive, it's consuming wise, it's a lot of traffic to move in and out for two agents that can be super consuming, whether it's a daemon set or in any other parameter, it will be very consuming. But even if we're doing this and we're doing the best practices with logging and monitoring, I think that something is still missing, and you might be able to agree with me. I think that the key point is two questions that are rising up. First, how do we correlate between metrics and logs? Or let me give you this scenario. We're having a 500 error somewhere in our system. Now, and this is we're seeing through Grafana or any other solution. Now, where do we know how to go on our logging solution? Let's say we're using Elastic, our own Elastic that we're running. How exactly do we know where we need this information? Or how do we filter that? Do we filter 500 and hope that it will get us to the right 500 error? That really becomes a pain, especially, again, in distributed systems such as running in Kubernetes cluster. Now, the second thing is, how do I correlate between different services? So we already know that it's not a single monolithic application, but instead it could split, 3, 5, 10, hundreds of services communicating with one another, which makes things super complex. And if let's say, for example, we know where the 500 error happened, and we'll get to that and we'll see the exception, but now we're seeing just a story of a single event, and we want to see the full chain of events that led me to this problem over the bad service. So for this exactly, we got distributed tracing. And again, guys, feel free to ask questions. I will address them throughout the conversation and not necessarily just at the end. This really takes me to distributed tracing, the ability to understand the trace over several services. Now, some people might complain that distributed tracing is very complex and they don't really understand what it is. So let me give you, what's the most straightforward definition for distributed tracing or trace. This is just a story. As you can see on the left-hand side, you can see a story. If you look at the numbers, you know exactly this story, where it moved from one service to another. I could probably show you this in logs, right? To show a log line of each and every service, you would have to, rebuild this or imagine it in your mind, what it actually looks like, which services are being communicating to one another, and what's the data. But a trace really built for the purpose of this. It tells me a story of how a request is propagated through different services. Now, since our system becomes so complex, having just the logs of each individual resource is not enough. I need to see the full path and then correlate it to the logs. Luckily for us, again, in here, we got some open source tools out there that can help us to accomplish what we're looking for with distributed tracing, connect the dots between the services. The most popular frameworks today are Open Tracing and Open Telemetry. And I gotta say it up front, Open Tracing, Open Telemetry, and Open Census are frameworks. They're not a service. You're probably familiar with things like Prometheus, which is a service that you spin up, or let's say Grafana or MongoDB or Redis or tons of other services, open source services that you can just run as part of a Docker container, and they're running. In this example, open tracing and open telemetry and also open census, it's not something that you're just running and it's there and you're having everything. It's just a framework. It's an SDK in the code that tells you what you exactly need to do in order to enable tracing, in order to run this tracing and connect the dots. It requires a lot of manual work. I'm going to show an example very much soon, and instrumentation, which can be very, very complex, when you're moving forward and your application is getting, more and more complex. In order to do this kind of tracing, you need to capture the before and after of every call. So once you capture that, you can extract the information, inject some information, collect the payloads that you need in order to extract it. And obviously, getting it started on a massive scale application would require a lot of heavy lifting. By the way, I haven't spoke about Jaeger, which I'm going to show soon. It's another open source that will help us visualize the traces, but that's a lot of work. And let me give you just an example. So this is an example for an incoming web framework. This web framework, for example, is Flask, and we're using open tracing in this kind of scenario. This is just a very small snippet of it. It's not meant to be readable. I mean, you don't have to go through each and every line. I'll just focus on the most interesting parts. So in order to actually do tracing, we need to first start with instrumentation. Instrumentation, in other words, is the ability to capture requests as they come in and out. For example, AWS SDK calls, HTTP calls, Postgres, Spring, Flask, Express, whatever module that you're using inside your code, that's a module that you need to instrument. So let's go with the basic thing, HTTP. Every one of us is making an HTTP call, either inbound or outbound. Once we capture that, we instrumented it into our code, we need to create a span once before the request. A span is a pretty simple term in open tracing that defines three things: an operation that happened in a specific time frame and took a certain duration. So for example, my operation can be a get operation that started a second ago and took 300 milliseconds, which sounds nice. But this alone is not very informative and definitely not distributed. This is just a singular span. In order to actually make it meaningful, I'll need to add some context. My context can be things like, what URL am I calling to? What's the status code in the response? Or anything like that that will help me, understand better what's going on. Now, since I'm doing distributed tracing, I need to send some signals in and out of, hey guys, I'm part of a trace 1, 2, 3. If you're listening, know that you're part of it as well. So when I'm making an HTTP call, I need to inject some ID. Let's call it correlation ID. It can be in any form, hex, hexadecimal, UUID, or any other format. I need to put it inside, for example, in the headers, where somebody will listen, will extract this magic header, this correlation ID, and will know that it's part of something bigger. Now, as you can see in this example, this is just the before request for an incoming call to my Python Flask application. I need to create a span to extract IDs, to generate the basic data of it, to set tags and context. This requires a lot of work that, is not very easy to do. And this is just for a single request for a single service in my application. This is a never-ending work. By the way, feel free again to ask any kind of questions over here, or let me know if you want me to focus on something specific. So I'm starting first with a distributed tracing use case. I'm having the following application, load balancer. This runs on AWS, by the way, as part of a Kubernetes cluster. So I'm having a load balancer, which calls to my Spring Web application whenever somebody wants to buy something on this virtual shop. I'm also using Auth0 for authentication. This is a third-party API that helped me make sure my users are authenticated. Then when this user is authenticated, I want to be able to push a message to someone to handle this. So currently I'm having a single queue or a single topic in Kafka that all it says, somebody wants to buy something. This endpoint, this single endpoint is buy something in this website. And I'm sending a message to Kafka for someone to handle this purchase. By then, we got a consumer another Java consumer application that consumes the message from Kafka and then charges the user. The reason for building this application this way is to be able to create async chain of events. this async chain of events allows me to return to the user a response quickly without waiting for what happens afterwards. In this example, by the way, it's pretty simple, but in real life scenarios, the afterwards can be very complex. For example, updating the stock and charging the user and updating his analytics and doing email confirmation and so on and so on. So it's getting really complex. Now, once we understand what's our application, we already know that this part, the Kafka, the Spring, and the consumer is running on Kubernetes. And we're having a scenario that some of our users complain that, they have orders that were sent out, at least, from the website, it looks like everything went fine on their front facing, but they don't see any confirmation. They don't see the charging over at the user. And now we're the one that need to roll our sleeves and troubleshooting. So starting first, let's drill into our Kafka metrics exist on my Grafana. I'll try to look and understand what happened. For example, how many calls, how many bytes. I don't see any major difference because still messages are coming in. So it wouldn't tell me a lot, but again, this is a nice dashboard. Lots of metrics, which might be vital when something goes wrong in the metrics. But in this example, it's not a metric for Kafka. I'll also try to look on the DynamoDB metrics to see if I'm having some errors or any kind of spikes or something. I do see some from time to time, but this actually doesn't tell me anything because, okay, last 6 hours I had a few or some errors, which it's not very good, but I need to troubleshoot it. How do I know exactly where do I need to troubleshoot or what happened? So, I'm trying my luck and I'm going to the Java logs, to the consumer logs to understand exactly what happened over there. So I'm rolling my sleeves and, reading tons of logs. Luckily for me, I can find somewhere some problems. I don't know even if that's correlated, but that's the logs that I'm seeing. Missing required parameter in input key, which makes some sense. This is the problem to the DynamoDB. If I'm a very experienced engineer, I know that it might be related. Otherwise, I might just miss this thing. But this so far been hectic. Like if I haven't been very much, into the details, it would probably take me a lot of time to understand what's going on. And, right now we did this in 10 seconds, 30 seconds. But in real life, this kind of understanding and going from one service to another can be very, very long, sometimes, even hours to get to the root cause of the problem. Instead of it, something that we want to see is a trace or a story, just as we've seen before. Remember the old graph that we saw before? So I would like to visualize that as a trace. This kind of trace is kind of interesting because it really visualizes the whole flow for me with load balancer, Spring Web, Kafka, consumer, DynamoDB, and auth0. Now, I don't want to look for the error in the logs. I don't want to understand where it happened. I just want to see the exception. And we can see that we got the same exception over here when we're clicking on the DynamoDB. This is the update item operation. This is the span that we're talking about that adds some error, which is nice. Now I can exactly understand where is the problem as part of the flow. But not luckily for us, we need to understand what happened. Why did the put item went wrong? Now, since this is a distributed system, it's not necessarily the consumer fault. It might come from somewhere else. So in this case, kind of a distributed nature environment, I would like to go backwards. For example, to click on the Kafka part of it to see exactly what happened or what message went through from this Kafka. And luckily, by the way, this is an example in Epsagon. I can refer to other questions afterward. But now I'm just taking you through the visual concept of how we want to troubleshoot such environments. And we can see that, for example, the username was empty, which definitely is not a good sign for something that happened in this case. So we want to go even backwards to the Spring service to understand exactly what happened in there, or even to the load balancer to see, what was the actual request or the HTTP call to auth0. We can see that ultimately the problem started with unauthenticated user. We can see the call to auth0, which in the response body by turn returned a 401, which probably all of you already know. 401 is unauthorized, but then you need to understand exactly why you got unauthorized. And we can see that our JWT has expired. So this ultimately problem that, if I would tell you there are two teams, one that handle the incoming request and then the other one that, handles the stock updates and so on, you would probably say it's the second team problem, the team that's responsible for the DynamoDB and the consumer part, but it actually started with the first service that didn't pass things according to the API. Due to some unexpected problem, something wasn't the right way or didn't, send in the right way that we're looking forward to do this. Just trying to have a broader picture to that. What's the Epsagon approach for doing tracing? So first of all, trace is a great thing that will help us, understand correlation between traces and logs, and even correlation between traces and metrics. For example, if I want to look in my Kubernetes nodes, pods, containers, or just jump between this and the traces, I can definitely do that. And this is important because I don't want to have Grafana, Elastic, Epsagon, another logging solution, another metric solution. I want to have everything under the same dashboard. I also want to be able to tag traces with my own ID, my own business application ID, things like identifiers like my customer ID, user ID, or other things that are important. Flow control, for example, how many times did the user purchase something versus returned an item. And also maybe business metrics, like how many items in the cart, how many minutes watched, anything that is part of your business that you might be interested in exploring. Now, Epsagon is also taking it to the next level with automatic tagging for this kind of tag. So anything that comes in the payload, just as we saw before with the Kafka, can be automatically indexed. So you don't even need to do this manually, but everything comes out of the box. And even take it to the furthest level of don't just send part of the information, send all of the information. For example, if I'm having an incoming HTTP, let's capture the headers or the body instead of capturing just a single IDs. If I'm having a query or some operation to a SQL or NoSQL, show me the actual query or the key that I'm doing. And again, for any kind of operation, just show me everything. Just to wrap up quickly, some of the best practices in observability. If I manage to convince you that observability is important and tracing would be a good part for your system, let me share with you something very quickly. So, first you want to look for something that is automated as much as possible, and minimal maintenance, because if you're doing modern applications, you probably want to have as simplest environment as possible, as simplest observability tool. You don't want to work for observability, you want it to have out of the box. And definitely something that will be able to visualize your environment, whether it's Kubernetes, other kind of containers, function as a service, serverless, or any other kind of environment. You want to make sure it will connect to every request in your system, whether it goes through Kafka, Rabbit, SQS, PubSub, or any other scenario. And you want to be able to, this tool to be able to analyze and pinpoint problems. So, removing the friction of looking at the logs and the metrics and trying to correlate and until you get to the point of the problem, this can be very, very problematic to do so. I'll jump quickly to the Q&A because I see actually some good questions over here. So one of the questions I see is about the dark slides, or some of the screenshots are kind of not very clear. You can look all at demo.epsagon.com. I will type it now for having more clarity. This is an environment that contains everything that I've just presented, and you can explore it for yourself. Let me try maybe to send it as a link, demo.epsagon.com. Yeah, hopefully this one is a link. So you can get into that and explore it further more on live environments on your end. Now, regarding can Datadog be used? So Datadog is a great tool, but honestly, Datadog is good at metrics and infrastructure level information, which can be good sometimes, but when you need to understand distributed system, you don't want to have fractions of it, logs in one part of the system or one part of the product, and distributor tracing another part of the product, and APM and metrics. You want to have everything under the same flow. And the flow that I've showed before, if I'll go back, something visually that shows you all of the information and all of the relevant data. As in this example, you had a call to an HTTP resource, it returned 401, you want to be able to pinpoint, generate information based on it, business metrics, correlate everything all together. This you probably can do with Datadog. You can probably build it on your own in any other way, but it would just take you tons of time, where with Epsagon is just as simple as putting the SDK to work, and that's it. You don't need to deploy any extra daemon sets or any extra containers or any extra other things as part of your stack. It's just a simple way to go, and you're getting much clearer visibility into your old stack in an automated way. when supporting this technique. That's right, we're also using similar things in our end in order to make sure we capture things from one context to another. So that's definitely something that is right. Thank you, Paul, for this note. And just as a summary for wrapping up this session, so we understand that modern application requires more than just basic monitoring. I mean, dashboards on Datadog is nice, but you need something that will actually show you the flow, the payloads, tagging, build custom dashboards on top of it, which is super crucial. And distributor tracing becomes the most important part. It's not just individual metrics, but the composition of all of them together. Try to evaluate several tools. Even if you're using Datadog, compare it to some other solutions just to understand what are the capabilities that you can get. And this is a tip from me to all of you. Try to avoid as much any kind of manual work. This contains a lot of work if you'll do it on your own. That's really hard to maintain and grow with. And that's it. Thank you very much for everyone for joining. You can look me up on Twitter or just hit me on the email. There is a special offer for everyone here today on DeveloperWeek, epsagon.com/DeveloperWeek. I'll post the link very soon. And really soon, I'm going to open up the speaker office hours, so you can join me there for any further questions or information. Thank you very much, everyone, for joining. It's been a pleasure.